Hi students, this is Mrs. Tran-Bloom recording for our brand new unit, section 2.1. So today we are going to study or review for some of us factoring the greatest common factor and factoring by grouping. So you guys do have some vocab here. The first one is called a factor, or in this case factors, okay? So a factor is a number or an algebraic expression that divides another number or another expression evenly. Evenly means we should not have any remainder. So some example is right here. It says find the factors for 12. So some of you said, well, the factors for 12 could be 3 times 4. Now, why are we using the word divide in the definition? Because 12 divided by 3 evenly gets 4 with no remainder. Now, the other factors could be 2 and 6. Same thing, right? We can do 12 divided by 6 is 2, or 12 divided by 2 is 6. And of course, we can also have 12 and 1, because 12 times 1 is 12, okay? So that's how we find the factors for our math definition. Now, right now, I would like for you to do this question. Give me the factors for 45. Remember, your answers will vary, okay? So go ahead and write that in, box that up. You can do the dot, whatever numbers you have. You can even do a comma, right? So something like that. Now we are going to go a little bit further in a definition called prime factors. Prime factors are prime numbers that divide that integer exactly. So now, very similar to the factor definition, except now we can only have prime numbers in our factors list. So same exact number here. Find the factor for 12. Well, the factor for 12, if we break that up, so 12 is really 4 times 3, right? Well, 3 is a prime number, so we can definitely circle that up, but 4 is not a prime number. So we go further. 4 is 2 times 2. Well, 2 is now a prime number, so we now have factors for 12 would be 2 times 2 times 3. So those are called prime factors. Now, the definition for the word term or terms. We are going to have multiple terms in an algebraic expression, so we need to know what that means. So a term is when it is a number or a variable. Okay, one number or one variable, or the product of number and variable is called monomial. It's separated by a plus or a minus sign. Okay, so usually we want to look at the separation by plus or minus sign. A monomial is one term. Okay, so that means there shouldn't be any plus or minus sign. We can have a negative monomial. So I'm going to give you some example. A 2 is a monomial because it's one number. But we could also have 41x to the 100, y to the 11th power. That's also a monomial. It's not multiple terms because it's not separated by a plus or minus. Mind you, we can also have negative, right? So negative 11w. That's also a monomial, okay? Now, a binomial meaning 2. So bi means 2, tri means 3, mono means 1. So 2 terms. So we can add these together. So 2 plus 41, x to 100, y to the 11th. That's a binomial. Or we can do negative 11w, let's see, minus or plus 4. Okay, that would also be a binomial. Just like earlier, this is 3 terms. Okay, 3 terms mean we have x squared plus 4x minus 11. We got 3 terms here. Sometimes we're going to see negative 49xw y to the 99th power. That's one term, minus 4x plus 100. So as you can see, each term is separated by a plus and minus. So this is term number 1, term number 2, and term number 3. Okay, term 1, term 2, term 3. Okay, Now, polynomial, it's two or more. So technically a binomial and a trinomial would constitute a polynomial. But usually we kind of use it for like 4 or higher, okay? Because we don't want to sit here and call it quadnomial or quintuplet. Okay, so anything higher than a 3 term, we kind of group it in this thing called polynomial. So a polynomial, it's more than 2, but we use it for 4. So for example, could be 2x squared minus 11x plus 4wx minus 4, something like that. Okay, so that would be a polynomial since it has more than 2 terms. In this case, is 4. Definition of a great common factor. Oftentimes you will hear your teacher say GCF. This is the largest, okay, factor. So we remember factor is the definition above where we have, let's roll up, okay, a number or an algebraic expression that divides another number or expression evenly. So 3 or 4, okay, those are factors of 12. So the greatest, just like in its name, okay, is the biggest or the largest factor that all of the terms have in common. That's what they share. So for our notes today, example 1 to 4 states, factor out the greatest common factor and check by using the distributive property. So remember, we need to know how to factor, right? The biggest term that these trinomial have in common. So let's always, okay, look at the numbers first. So you have 9 students, that's 3 times 3. Then we have x to the 4th, that means you have x times x times x times x. Okay, so that's 9x to the 4th. Now we have 3x to the cube. Well, 3 is really 3 times 1. And that means x to the 3rd means x times x times x, okay? I'm doing this very basic right now so that way you understand where it's coming from. Now your 12 students, that's going to be 4, okay? So 12 is 4 times 3, but 4 is not a prime number, so that's going to be 2 times 2. So 12 is really 2 times 2 times 3. So your goal for the numbers is always try to see if you can break it down to prime numbers, if possible. Now, some of you guys already know how to do this. If you know how to do this, just go and do it your method and just check back with the answer. So what is it that they have in common? Okay, they all have a 3 in common. Okay, so that's all they have for the numerical value. Now, if you look at each one, they all have x squared in it. Okay, so that's your GCF. GCF, students, is 3x squared. So when we say factor it out, students, that means it goes in the front of your answer like this. Okay, then whatever's left, we put it inside. Now, how do we decide what's left over? We take each term and we divide it by the GCF. So each term divided by the GCF, each term divided by the GCF, just like that, okay? Now, if you wrote it like this, then it's the same thing, okay? Divided by, so I'm showing you students how to do it in multiple formats, okay? Again, if you remember how to do this from Algebra 1, go ahead and do it without looking at this, and that's totally fine by me. So if we take 9 divided by 3, it's going to be 3, okay? Or if you do this way, then that's going to cancel. This is 2 x's, so that would cancel. So that means we are left with a 3x times x, that's 3x squared, okay? Now, if you go and divide this and that, and then those two would cancel with that, then that is going to be left with 1x, okay? Drop down your plus sign. 1 times x is just simply x. Similarly, over here, that would cancel with that. Those would cancel, so that means this last term has 4. Okay, so here is what we have for our answer. When you factor it out, your GCF goes in the front, and whatever's left over, it's on the inside. Now, your direction says and. Check it by distributive property. So let's copy down our answer so we can start using the distributive property to multiply it back to see if we get the same answer. Okay, now some of you guys already know how the power, aka exponent rules, work. Okay, so when you multiply this back, it's 3 times 3, and then x squared times x squared. Now, if you already know how to do this, you can go to a straight 9x to the 4th. When you multiply powers, students, you add the powers, okay? Then we're going to take this right here. Remember, this is a 1 right here. So this is really, drop down your plus sign, is 3 times 1. Then you have an x squared from the outside. This really has a power of 1 as well, so that's x to the first power. This, again, students, if you can tell me that this is 3x to the 3rd, because we add the exponent, then go straight there. Then we're going to take 3x squared times 4. Now, the 4 does not have any variable, so we multiply the numbers together, just like that, and then the outside term has a square, so we're going to leave it like that. So this ends up as being 12x to the 2nd. Now, look at this for me, and look at our OG expression. They should be exactly the same. So if it's the same, you did great, and then you move on, okay? Number 2, so 16m squared plus 12mn. Again, break 16 down, okay? So 16 is going to be 4 times 4. Okay, we'll break it down a little bit more. Now, m squared is technically, students, that's m times n. 12 is 4 times 3. And then the m and the n, they are independently by themselves because they are not any square power or third power. Some of you said, well, I don't want to factor to prime number because I can tell right now they both have a 4 in common. This has an m in common, so what that means is that's going to be your GCF, greatest common factor. So we factor out a 4m. That means we will be left with whatever you factor out, okay? That means we're dividing each term by the GCF. When you divide by the GCF, it's going to be reducing the 4, reducing the m. Same thing with over here, reducing the 4, reducing the m. So we are now left with a 4m, students, plus 3n. So this is our final factor answer. Now remember, it says for us to check it. So copy it back down, okay, to check it, meaning that we want to make sure when we FOIL this back or distribute this back, we get the same exact as the original. So you got 4m times 4m, okay? Then this one over here plus 4m times 3n. We always put the numbers together and the variables together, okay? And remember, as mentioned earlier, if you already know how to get straight to the answer, you are more than welcome you're more than welcome to go straight there and not have to do all of this work. So 4 times 4 is 16. We have a power of 1, so 1 plus 1 is power of 2. Over here, 4 times 3 is 12. These cannot be combined because they are different variables. So this one, students, let's check to see if it matches our original. Yes, it does. And then we can do a happy dance, okay? Now, I would like for you to give number 3 a try, okay? So I want you to do you try on 3. And all I want you to do to 3 is factor out the greatest common factor. Hopefully you guys all had recognized that their 3 is the only thing that these have in common, okay? I'm just going to go now straight to dividing each and every term by 3. So that will end up with 1x squared, or simply just x squared. And then remember, drop down the minus sign, but 6 divided by 3 is 2, and the x is still on the top. Then drop down a minus sign. 30 divided by 3 is 10, okay? This is right now, students, all we are going to do because this one says factor out the GCF only. Later, we will factor more with that remaining trinomial, but right now, that's all I want you to do, okay? Now, when we FOIL this back, we're going to write 3 times x squared minus 2x minus 10, okay? Distribute that out. That will give us 3x squared. Distribute that out. 3 times negative 2x is negative 6x. 3 times negative 10 is going to be negative 30. And that should be what we have up here. That means you factor it correctly. Yay! All right, this one, ooh, this is 4 terms, okay? So each one we need to, if you don't see the GCF, then go through and factor each one. 26 is going to be 2 times 13. You have 4 x's here on that first one. Okay, so think about it like that, and you have one single y, so that's that first term. Then minus, it's just dropping the sign down. 39 students is 3 times 13. And then you got 3 x's, 1, 2, 3, because x to the third power. Then this is y squared, so that means you have 2y. And no, you don't need to write all of this out if you are really good with factoring the GCF. Now 52, I don't know if, let's just think about it. If you don't have a calculator, it's okay to just start with a 2, okay? And then you can do the next step and factor out some more. 52 is even. We know it has to be divisible by 2. And so 2 times 26 is 52, okay? And then I know that x squared is x times x and y is 3y's. So I'm going to write all of the steps out. Eventually, I'm not going to write all of this out because it's our first time seeing this for some of you, or first time in a long time, okay? And then negative 13, I'm going to 13 times 1. Those are the 2 factors. And then simply x, and then you know there's 4 y's. 1, 2, 3, 4. Okay. Now, as you can see here, this 26 can be broken down some more, right? So that's really 2 times 13. So this whole thing right here could be rewritten as 2 times 2 times 13. So if we look through each and every one of this, they all have 13 in common. That is we're going to write GCF, okay, and then we're going to write 13. Now let's look at how many x's we have. Now, guys, there's 1 y here, 2 over here, so that means there's at least 1 in common. There's 3 over here, so that I know there's 1 in common, and there's 4. So we all know right now there's at least 1 y, okay? Now let's look through the x's. You guys can see that there's 4 here, 3 here, 2 here, and 1 here. So we know that they all have 1 x in common. So when we write the GCF, we normally write it in alphabetical order with the number being the very front. So we will take 13xy out, meaning whatever's left over is going to be put in this bracket. So divide each and every term by 13xy. 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 And no, you don't have to go through this process if you can go and do it all on your own without writing all of this out. 13 divide, cancel 1 of the x's, cancel the y. 13 divide, cancel the 13s, 1 of the x's, 1 of the y's. And then 13 is going to be canceled 13, x is going to be canceled 1 of the x's, y is going to be canceled the y. Similarly to this. Whoop, 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 whoop. Okay, so the very first term, we are left with a 2, 3 x's. Okay, so that's 2 and x to the third. The second one, we are left with a 3, 2 x's, and a y. So that's going to be minus 3x squared and a y. Then this one, we are left with 2 and a 2. So that means we're left with a 4, okay? And we're left with 1x and 2 y's. So that's going to be x and y squared. Over here, we're technically left with a 1 and then these 3 y's. So you can definitely write 1 y to the third or simply y to the third. And this is our final answer that we can box up. Okay. Now let's see if we can, when we multiply this back, it will give us the same as our original. So 13x times y times the quantity of 2x to the third minus 3x squared y plus 4x y squared minus y to the third. Now, if you have a hard time seeing the powers, if you don't ever see 1, just put a 1 right there. And even the leading coefficient, go and put a 1 just like that. So you are aware that, hey, those are really 1s, okay? All right, 13xy times 2x to the third. That means it's 13 times 2 x, we'll put them together, x outside and then x 13 on the inside, and then we'll put y in the back. 13xy times 3x squared y, so minus 3 times 13. You have an x on the outside, x squared on the inside, 1y on the outside, and then 1y on the inside. Remember, I'm going to put all the common variables together. Similarly with this, okay, plus 13 times 4. We have an x on the outside, 1x on the inside, and then a y on the outside, and 2 y's on the inside. And last term is this little guy over here, minus 1 times 13. We have an x on the outside, a y on the outside, and a y third on the inside. All right, so let's see what we are going to end up with. So that's going to give us 26, okay? x1 times x to the third, you add the power, so that's x to the fourth. There's a single y right there. Minus 39, again, we have 3 x's because x1 and x squared is x to the third, 2y, so that's y squared. Now remember, this is 13 times 4. 1, okay, that's 10. 10 times 4 is 40. 3 times 4, that's 12. Okay, so that's going to give us, guess what? 40 plus 12 is going to be 52. I'm pinching in so that we can see that, hey, we're going in the right direction, okay? So 52, and then 2 x's, that will make it x squared. This is a power of 1, so that's y to the cube. Minus 13, we have 1 x only here. This has x1 and x to the third, so I'm sorry, y1 and y to the third, and y to the fourth. Now let's compare that, pinch it in, okay? Is that looking like that? And if you said yes, that means you did a good job in factoring. So these are the skies or guidelines for factoring 4 terms. When we say 4 terms, these are what we mean, okay, down here. Break the expression that you have into 2 sets of binomials. Remember, binomials means 2 terms each, okay? A equal A, break it in half. And then step number 2 says factor out the GCF from each set of binomial. Factor out the GCF from the entire expression. Write it as a product of 2 binomials. Now, start this after, guys. Check the GCF. Check factor GCF from the entire expression first, okay? Entire expression first. So let's go and try example 5 to 8. So example 5 says, we have 2x to the third, 5x squared, minus 4x, minus 10, okay? So if we look at just the numbers, 2, 5, 4, and 10, none of those, we are not going to have anything in common except a 1, okay? Because it's a 1, we don't need to take it out for the entire expression. We want it to have a GCF bigger than 1. Now, next look at the variables. X to the third, x squared, x, there's no x. So again, for this one, these 4 terms, we don't have the greatest common factor for the entire expression. So it says, now take your 4 expression, look at step number 1, and said break it into 2 sets of binomial, aka break it in half, okay? So that's what we're going to do. We are going to break it in half, and I'm going to use this fencing method. I want you guys to draw a fence right in the middle like that, okay? Just like that. Now, we are going to look independent of the first half to see what the first half has in common. Do they have a GCF? And as you can see, this has 3 x's, this has 2. So definitely x squared is what they have in common. And if they have an x squared in common, then we go and divide each term by x squared. Okay, that's how we factor. Take out the GCF, by dividing each term by the GCF. And whatever's left over, we put it in the parentheses. So 2x to the third divided by x squared, we have 2. X to the third on the top, and we have x squared on the bottom, we definitely would have 1x left. 5x squared divided by 1x squared, or x squared, we would get 5, okay? Because the x squared and the x squared would cancel. Over here, we would have 1 left because this has a power of 3 and this has a power of 2. When you minus the powers, you would have 1 left. Now over here, you have the second half here, students. You have a negative 4x minus 10, okay? They both have a negative, okay? So if you see there's a negative here, bring that down. Then look at the numbers. They both are going to have a 2. So in this case, they have a negative 2 in common. So you can divide each and every term by a negative 2. Let me erase this little extra line. Just like that. With that said, we are going to open up our parentheses and close and put whatever's left over. Now we have a negative 4 divided by negative 2. That will give us a positive 2x left over. A negative 10 divided by negative 2, that will give us a positive 5 left over. So can you see that? Now this is important, the next step. These, okay, and these, they have a common group, okay? That's a factor. A common factor could be a group. So we will take that out and put it in the front, just like this, okay? When we take that out, that's the same thing as saying, okay, we'll divide each side by this quantity, just like that. And if you guys remember how to factor this from Algebra 1, you can go through it pretty fast. And I mean, this is gone, right, because they reduced. This is gone because they reduced. So the leftover goes in the parentheses again. So that's going to be x squared minus 2. So guys, this right here is how you factor 4 terms. So the factors are 2x plus 5, that's one factor. That first group is one factor. And then x squared minus 2, that's a second factor. They just happen to be a binomial for each factor. All right, guys, so example 6, we have x to the fourth plus 7x to the third plus 5x squared plus 30x. Remember, always check GCF first, okay, from the entire expression. We have 4 x's here, x to the third, x squared, and an x. So clearly they all have an x in common. This has a 1 right here, students. So none of them have a number in common besides a 1. So we don't factor out a 1. I mean, technically, you could say like 1x, okay? But that's the same thing as just factor out an x, just like that, okay? So the leftover goes here. So when you factor it out, we are going to divide each and every term by x, right, guys? Just like that, okay? Dividing means you are subtracting the power. So x to the fourth divided by x. That means we have x to the third left. 7x to the third divided by x, we will have 7x squared left. 5x squared divided by x, we are going to end up with 5x left. 30x divided by x, we are going to end up with 30. Now, it has 4 terms, okay? So what you need to do next is make it into 2 equal groups, okay? AKA break it in half and check to see if we can factor further. So the first group, as you can see, has, we're going to save this answer. This original GCF will go out in the front here, okay? So we have x to the third here and x squared. So that means we know that has to have an x squared in common. So x to the third divided by x squared. Remember, every time you take out a GCF, it's like a division. So that means we have 1x left because x to the third divided by x squared, you minus the power, plus 7x squared divided by x squared is now a 7, okay? This right here is a positive 5, so drop down the positive. Looks like they have a 5 in common, so take out a 5, so that means you divide it like this. So 5x divided by 5, guys, is x. 30 divided by 5 is 6. We are going to look, okay, at these now. Do they have anything in common? So for example, we have x plus 6 and then x plus 7. That's not the same. Wah, wah, wah. So that means this 4-term polynomial expression here, it's not possible to factor further. So what that means is, even though we can only factor out the GCF, but that's good enough, okay? So we're gonna write this over because that is as far as we can go with this polynomial. So factoring completely, sometimes you need to go further, but sometimes the GCF is as far as you can go. All right, let's try example number 7. So on 7, okay, actually, you know what? I'm going to do one of these, and then one of them I'm going to leave it for you. I feel like example 7 is slightly easier, so I'm going to go and do example 8, and then I'm going to ask you to do 7 on your own, okay? All right, so example 8. 3x squared minus 15x minus 40 plus 8x. Notice how when I first read this out, the powers are not they're not in order. So if it's not a requirement, but it's easiest, students, if you write them from highest power of your variable to the lowest power. Okay, so we go from 3 to 15x to the first minus 40. And so this one, check for GCF. Ready? 3, 8, 15, and negative 40. Negative 15 I meant. None of them, besides a 1, we don't have anything in common. Okay. And then we have x to the third, x squared, x to the 1, and no x. So clearly we don't have a GCF bigger than 1. So we don't need to take anything out. So now we're going to break this, make this fencing. Break it into 2 equal halves. On the front, 3 and 8, just like earlier, nothing in common. So, but we do have x to the third, x squared. So that means we can take out x squared. That's the biggest we can take out. If we take out x squared, that means we are going to divide this by x squared, divide this by x squared. So 3x to the third divided by x squared, we will subtract the power. So now we have 3x. 8x squared divided by x squared. If we subtract the power, no x's are left. Remember, if this is a negative, you drop it down right away because you're going to factor the negative number then. 15 and 4, definitely a 5 in common, right? Okay, so divide this by negative 5. Remember, we factor out a negative 5 here. So divide each side by negative 5. So what that means is the leftover will go in the quantity set. Negative 15x divided by negative 5, students, is positive 3x, okay? Negative 40 divided by negative 5 is a positive 8. Now compare these. Is that quantity and this quantity, are they identical? If they are, that's a common factor, okay? So that means we do take that out. Ooh, that is way too big. All right, let's do this thinner, okay? So that's going to be 3x plus 8. That's a factor that they both have in common. So remember, a factor means something that we factor out, meaning that we go and divide each term. Well, if we divide it, cancel, 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 cancel. So you are left with an x squared minus 5, and the leftover goes on its own, right? Its own set of quantities. So that's how we box up our answer. Now, I would like for you to do 7 on your own. So you try. Guys, hopefully you guys ended up with the 2 factors like what I have here. So the first factor is x minus 4 times a quantity 10x squared plus 3. Now, some of you said, well, is it okay if I write this factor on the front? Yes, okay. In multiplications, guys, order doesn't really matter. On any of our factors, you can always put the factor in the front and the other factor in the back. It's not important, okay?